Hi friends, today's topic is midpoint ellipse algorithm. So the ellipse equation is x square by rx square plus y square by ry square is equal to 1. If rx and ry are the radius on x axis and ry is the radius on y axis. So our concept is we are drawing the ellipse by using midpoint. For example, if a point is xk, yk and we have to identify the next coordinate. Next coordinate is xk plus 1 comma yk plus 1. If we know the first point, based on this first point we have to identify the next point. So in the process of calculation, ellipse follows some symmetry property. So symmetry property means, for example, this is an ellipse. Radius on x axis is rx, radius on y axis is ry. The property of ellipse is all four quadrants are same. That means we are calculating the points of only one quadrant. By using these quadrants, we are identifying the remaining three quadrants. For example, if a point is x comma y in this coordinate, simply the point is minus x and minus y on this coordinate and x comma minus y on this coordinate, minus x and minus y on this coordinate. That means we are calculating only one coordinate. Based on this we are identifying the remaining three coordinates. And one more property of the ellipse is divided into two regions, R1 and R2. So for example, we are starting at this position. From this position to we are moving up to this position. So in the process of deriving the points, whenever the region 1 is completed, we are enter into region 2. So the region 1 and region 2, the boundary point is slope. That is, the slope is equal to minus 1. That means region 1 is completed. We are entering into region 2. So the condition for moving from region 1 to region 2. For example, observe this point. X square by rx square plus y square by ry square is equal to 1. Ellipse equation is x square into ry square plus y square into rx square minus rx square and ry square. Simple LCM term. That means here slope is equal to minus 1 means dy by dx is equal to minus 1. Perform dy operation on this term. Here dy means only y coordinates are considered. Remaining all terms are treated as constant. That is the derivation. So x, this is 0. Y square into rx square. Dy of y square into rx square means 2y rx square. And this is constant by dx. 2x into ry square is equal to minus 1. That is, we are moving from region 1 to region 2 whenever this condition is satisfied. Whenever this condition is satisfied, we are moving from region 1 to region 2. Now coming to region 1. Region 1 is unit x intervals. Unit x intervals. That means each time x value is incremented by 1, we need to find the y coordinate. So the first point is xk, yk, and the next point is xk plus 1 comma yk, or xk plus 1 comma yk minus 1. So we need to find whether the next y coordinate is yk or yk minus 1. That means we are starting from this point. The next y coordinate is either same point or decremented by 1. But each and every time x values moves from left to right. That is, x value is incremented by 1. Now the concept is midpoint ellipse algorithm. Calculate mid value. x1 y1, x2 y2. Mid is equal to x1 plus x2 by 2 comma y1 plus y2 by 2. That is xk plus 1 comma yk minus half. Now the decision parameter p1k. Here 1k means for region 1, the decision parameter is, that means f ellipse of xk plus 1 comma yk minus half is equal to, this is x term and this is y term. So xk plus 1 whole square into ry square plus y square, yk minus half whole square into rx square minus rx square or y square. This is decision parameter. Now p1k plus 1 is equal to simply xk plus 1 whole square into ry square plus yk plus 1 minus half whole square into rx square minus rx square into ry square. Simply write k plus 1. Perform p1k plus 1 minus p1k. p1k plus 1 minus p1k. So xk plus 1, that means the next x coordinate. The next x coordinate is always fixed, that is xk plus 1 whole square into ry square plus yk plus 1. Next to y coordinate is unknown. So simply write yk plus 1 minus half whole square into rx square minus rx square ry square. p1k plus 1 minus p1k, that means xk plus 1 whole square into ry square minus yk minus half whole square into rx square plus rx square ry square. These first and these two terms are cancelled. Now p1k plus 1 is equal to p1k plus a plus b whole square, that is a square plus b square plus 2ab, that means xk plus 1 whole square into ry square plus b square, that means 1 into ry square plus 2 into xk plus 1 into ry square plus, take the common term yk plus 1 plus yk plus 1 minus half whole square minus common yk minus half whole square into rx square minus this term, that means xk plus 1 whole square into ry square. Now these two terms are cancelled. This term and the last two terms are cancelled. Finally p1k plus 1 is equal to p1k plus ry square plus 2 into xk plus 1 into ry square plus yk plus 1 minus half whole square minus yk minus half whole square into rx square. This is the decision parameter p1k plus 1. After calculating p1k plus 1, the next procedure is whether p1k is less than 0 or p1k is greater than or equal to 0. Suppose the p1k value is less than 0 means the coordinates are xk plus 1 comma yk. xk plus 1 comma yk. Substitute p1k plus 1 is equal to p1k plus ry square plus 2 into xk plus 1 ry square plus yk plus 1 is replaced with yk, that means yk minus half whole square minus yk minus half whole square into rx square. So p1k plus 1 is equal to p1k plus ry square plus 2 into xk plus 1 into ry square. This is P1k, its value is less than 0. If this is replaced with simply 2xk plus 1, that means simply the next x coordinate, and next term is P1k is greater than or equal to 0. The next y coordinate is x coordinate is fixed, the next y coordinate is yk minus 1. So P1k plus 1 is equal to P1k plus ry square plus 2 into xk plus 1 into ry square plus, in this term yk plus 1 is replaced with yk minus 1. That means yk minus 1 minus half whole square minus yk minus half whole square into rx square. Now P1k plus ry square plus 2 into xk plus 1 into ry square plus a minus b whole square, that is yk minus 1 square plus 1 by 4 minus yk minus 1 minus y square k plus 1 by 4 minus yk into rx square. P1k plus ry square plus 2 into xk plus 1 into ry square plus y square k plus 1 minus 2yk plus 1 by 4 minus yk plus 1 minus y square k minus 1 by 4 plus yk into rx square. So a minus b whole square formula. And next P1k plus ry square plus 2 into xk plus 1 into ry square. Observe any terms are cancelled or not. Y square k is cancelled with y square k. 1 by 4 is cancelled with 1 by 4. Yk and yk, two terms are cancelled. So 1 plus 1, 2. 2 minus 2yk into rx square. And finally P1k plus 1 is equal to P1k plus ry square plus 2 into xk plus 1 into ry square plus 2rx square minus 2rx square yk. This is the equation whenever pk value is greater than or equal to 0. So again, if you want to simplify, the equation is P1k plus ry square plus 2xk plus 1 ry square. That means the next x coordinate minus 2rx square yk plus 1. Yk plus 1 means the next y coordinate. The next y coordinate means here yk plus 1 is replaced with yk minus 1. That means minus 2rx square into yk minus 1. This is the equation. So up to this one is sufficient. Suppose again if you want to simplify, this is the final equation. After calculating these 2 points, we have to calculate the initial decision parameter. And now the initial decision parameter is so the point is 0 comma ry. That means in the ellipse we are starting from this point. This point is the y value is ry, the x value is 0. So 0 comma ry. So midpoint is x1 plus, that means xk plus 1 comma yk minus half, that is 0 plus 1 comma ry minus half. So initial decision parameter P0 is equal to x square into ry square plus y square into rx square minus rx square or y square. So ry square plus ry square plus 1 by 4 minus ry into rx square minus rx square ry square. So this means ry square plus rx square into ry square plus 1 by 4 rx square minus ry into rx square. So these terms and these terms are cancelled. The initial decision parameter is equal to ry square plus 1 by 4 rx square minus ry into rx square. Now the region 1 is completed. Next we will move to region 2. In region 2 we are considering unit y intervals. Unit y intervals, that means we have to identify the next x coordinate. So the next x coordinate is either xk or xk plus 1. So y coordinate is fixed, that is each time y value is decremented by 1. So initial point is xk comma yk. The next point is either xk comma yk minus 1 or xk plus 1 comma yk minus 1. So similar to region, calculate mid. Mid is equal to x1 plus x2 by 2, that means xk plus half yk minus 1. So calculate P2k. So region 2 decision parameter x square into ry square, that is xk plus half into ry square plus y square yk minus 1 y square into rx square minus rx square ry square. P2k plus 1 is equal to xk plus 1 plus half into ry square plus yk plus 1 minus 1 whole square into rx square minus rx square or y square. Similar procedure, P2k plus 1 minus P2k is equal to xk plus 1 plus half x square into ry square, xk plus 1 plus half into ry square plus yk plus 1. Yk plus 1 means the next y coordinate. Next y coordinate fixed, that means yk minus 1 whole square into rx square minus rx square ry square minus P2k terms. P2k terms means xk plus half whole square into ry square minus yk minus 1 whole square into rx square plus rx square or y square. That means cancel these two terms. Xk plus 1 plus half whole square. So observe common terms, xk plus 1 plus half whole square minus xk plus half whole square into ry square plus simplify this term. By simplifying this term, a minus b whole square yk minus 1 whole square into rx square plus 1 square into rx square minus 2ab, that means minus 2 yk minus 1 into rx square, and this term minus yk minus 1 whole square into rx square. So P2k plus 1 is equal to P2k plus, so this term xk plus 1 plus half whole square minus xk plus half whole square into ry square plus yk minus 1 rx square yk minus 1 rx square, these two terms are cancelled, plus rx square minus 2 into yk minus 1 rx square. This is P2k plus 1. After calculating P2k plus 1, again the same procedure. The procedure is check whether P2K value is greater than or equal to 0 or less than or equal to 0. Suppose in this case, if P2K value is greater than 0, exactly reverse to the previous procedure. In the previous region 1 is less than 0, that means the same y coordinate. Here it is greater than 0, the same x coordinate. So xk comma yk minus 1. So similarly substitute in this equation. So in this equation means P2k plus 1 is equal to P2k plus xk plus half whole square minus xk plus half whole square, that is xk plus 1 term is xk, that means simply 0 plus rx square minus 2 yk minus 1 into rx square. So the equation is P2k plus 1 is equal to P2k minus 2 into yk minus 1 into rx square plus rx square. This is the equation. So minus 2 into yk plus 1, 2 into yk minus 1 rx square is replaced with 2 yk plus 1 if needed. P2k is less than or equal to 0. The next point is xk plus 1 comma yk minus 1. So again substitute. P2k plus 1 is equal to P2k plus xk plus 1 value is xk plus 1. That means xk plus 1 plus half whole square minus xk plus half whole square into ry square plus rx square minus 2 into yk minus 1 into rx square. P2k a plus b whole square, that means xk plus 1 whole square plus 1 by 4 plus xk plus 1 minus xk plus half whole square into ry square plus rx square minus 2 into yk minus 1 into rx square. Again P2k plus a plus b whole square x square k plus 2 into xk plus 1 plus 1 by 4 plus xk plus 1 a plus b whole square, that is x square plus 1 by 4 means minus 1 by 4 minus xk into ry square plus rx square minus 2 into yk minus 1 into rx square. X square k and x square k terms are cancelled. 1 by 4 cancelled. xk and xk are cancelled. Finally P2k plus 1 plus 1 only 1. So 1 plus 1 2. So x square k plus 2xk plus 1 plus 1 by 4 plus xk plus 1 minus x square k. So 2 into xk plus 2 into ry square plus rx square minus 2 into yk minus 1 rx square. This is the final equation. Suppose if you want to simplify the equation, P2k plus 2 xk plus 1 ry square plus rx square minus 2yk plus 1 rx square, where xk plus 1 value is xk plus 1, yk plus 1 value is yk minus 1. After calculating these decision parameters, calculate initial decision parameter for region 2. Initial decision parameter for region 2. For example, region 1 completed at position x0, y0. That is the last point of region 1 is x0, y0, And for region 2, the midpoint is xk plus half comma yk minus 1. That means the point is xk plus half comma yk minus 1. So here xk is x naught, yk is y naught. That is x naught plus half comma y naught minus 1. Again similar procedure. Substitute x square into ry square plus y square into rx square minus rx square y square. That means x simply x naught plus half whole square into ry square plus y naught minus half whole square into rx square minus rx square ry square. Whenever we know x naught and y naught value, we are identifying the initial decision parameter for region 2. This is the midpoint ellipse algorithm. Next we will consider an example.